हेलो एवरीवन। केम छो? कैसे हो आप लोग? हेलो एवरीवन। केम छो? कैसे हो आप लोग? कैसे हो आप लोग? और सब बढ़िया। हेलो एवरीवन। कैसे हो आप लोग? तो आज स्टार्ट करते हैं पीएनसी से। परमुटेशन एंड कॉम्बिनेशन। ओके, so let's continue with permutation and combination. Let people connect. ओके, थोड़ा टाइम देते हैं उन लोगों को। तो इसके बाद हम लोग पूरा स्पीड में रहेंगे और सारे टॉपिक को आज कवर कर लिया जाएगा पीएनसी की में वन शॉट में, है ना? तो लेट्स वेट फॉर सम टाइम। पीएनसी विच इज वेरी माइंडफुल सब्जेक्ट, इसमें दिमाग लगता है। ये दिमाग वालों के लिए सब्जेक्ट है। और हम लोग आज बहुत बेसिक से जाएंगे। विल कंटिन्यू विथ फ्रॉम द बेसिक्स। पीएनसी अच्छा हो जाएगा तो प्रोबेबिलिटी में कोई प्रॉब्लम नहीं होंगे। पीएनसी वन शॉट लाइव स्ट्रीमिंग। तो थोड़ा वेट करते हैं। और सब चीज बढ़िया चल रहा है ना? लाइक स्ट्रीमिंग एंड एवरीथिंग, दिस इज गोइंग फाइन। आई थिंक you are able to see this video very nicely, very frequently. ओके, तो अब हम लोग अपना जर्नी स्टार्ट करते हैं. वी गेव इनफ टाइम टू ऑल पीपल टू कनेक्ट. यस, लेट्स स्टार्ट आवर जर्नी. ओके, people are ready to connect us live. Okay, so let's continue the journey. So what do you mean by permutation combination? This is my first question to you all. What do you mean by permutation and combination? So permutation meaning arrangement and combination meaning different way of keeping them. Okay. So permutation meaning arrangement and combination meaning different way of keeping them. Okay. So let's move ahead. So in permutation, like in order to become expert in any technical thing, like how to apply formula for permutation, how to apply formula. So it will be right now difficult for you all to apply, isn't it? So we will continue with technical things like how to apply formula for permutation, how to apply formula. So it will be right now difficult for you all to apply, isn't it? So we will continue with so hello Pranav, hello everyone. Just let's continue. Hello. Okay. Okay, so let's continue. Okay. So fundamental of counting. Fundamental of counting meaning we have to count. We have to count and try to find like what are the different methods. So how many different ways are there to perform a question. Okay. So if I tell you, if I tell you a simple example. So if I take a simple example like find the number of ways find the number of ways in which. So we will be solving this all question using fundamental principle of counting. We'll count. We'll see how the things are happening. We'll draw the diagram. We'll draw the line connecting one point to another point. And based on that, we'll count everything and we will try to find the answer. Okay? In which one can travel from town one, that means T1 to town 3, that means it is T3. So the number of ways in which one can travel from town 1 to town 3 via town 2, that means T2. So they will have to pass through T2. So it's like T1 is here, they have to go to T3, and in between we have T2. Okay? So how many different ways are there? So for example, I take that from town 1 to town 2, this is the way, and town 2 to town 3, we have these many ways. Okay, 1 and 2. So now you should be telling me that what are the different number of ways from which we can go from T1 to T3. If it is given that T1 is connected to T2 through 3 ways and T2 is connected to T3 through 2 ways. So how many different ways could be followed? So if you ask me, I will tell you that it is better we go from T1 to T2. We'll consider this as R1, this is R2, this is R3, this is R4, this is R5. We'll tell that T1 will go from T1 to T2 through R1, and then from T2 to T3 it will go through R4. Okay, and now this is the one method, we call it one method. Second, T1 will go to T2 through R2 only, R1 only, and at the end from R5. Can it be possible? Can it be possible? Yes, sir. Third, T1 will go to T2 through no different way, maybe R2, okay? And from T2 to T3, it will go through one of them, which is R4 first, and T1 will go from T1 to T2 from R2, and the last point will be from R5. So what are we doing? We are doing multiple combination. We are going from R1 and first time taking R4, second time R5. So R4 and R5 In second, we are going through R2. First, we are taking R4 and then we are taking R5. So now we are left with last two combination. Like we are from T1 is going from T1 to T2 through R3 and T2 to T3 through R4. Again, now T1 is going to T2 through R3 and finally from here to T3 using R5. So if you see, we have covered almost every type of cases, isn't it? We have almost covered first R1, then second R4, first R1, then second R5, first R2, then second R4, first R2, then second R5, first R3, second R4, first R4, R3, second R5. So we have taken all the five cases. So total number of ways are how much? 6. And if you see, we can say that here we have 3 and here we have 2. So choose any one of the 3, that will be 3 and then 2, which is 6. Got it? Okay. So fundamental principle of counting consists of this type of model. This is now model number 1. Okay. Now if we go to model number 2, okay, we'll keep it model number 1. So this is the model diagram. In order to understand any question, this type of diagram we'll make to understand. So model 1 already done. Now we are on model 2. In model 2, if we have some question like this, if we have a question somewhere like this, so model 2 could be represented in this way only, like uh, find number of ways by which everyone you should be trying. Okay, find the number of ways by which a person enters okay. So which a person enters, find the number of ways by which a person enters and live cinema hall by different doors. So we have to first take that We will be first taking this, okay? So there is a cinema hall. So we are making a hall. So this is the cinema hall. We have this as door 1, this as door 2, this as door 3, this as door 5, this as door 6. So we have 6 doors, isn't it? So this is door 1, this is door 2, this is door 3, this is door 4, this is door 5. A person will enter through one of the door and he will have to come out with some different door, not the same door, okay? So what diagram would come out to be? This is a person, P is a person, he will enter through D1, he can enter through D2, he can enter through D3, he can enter through D4, he can enter through D5, he can enter through D6. So he has 6 different options. Now when he entered from D1, he need to come out from different door. That means for him the option is D2, D3, D4, D5, D6, isn't it? So other than D1 he has this much option. When he goes inside from D2, he has option as D1, D3, D4, D5, D6. Yes. Now if he enters from D3 and it is given that he cannot come out with the same door, then he has left option as D1, D2, D4, D5, D6. If he enters from D4, he has option as D1, D2, D3, D5, D6. Now if he enters from D5, he has option on available for D1, D2, D3, D4, D6. And if he enters from D6, he has option only left with D1, D2, D3, D4, D5. So you see that for D1, he has 1, 2, 3, 4, 5. That means for 1, it is 5 option. For second also, we have somewhere 5 option, 1, 2, 3, 4, 5. For third one also, we have 1 into 5. Fifth one also, 1, 2, 3, 4, 5. Fourth one. Similarly, if you go for this one also, we have 1, 2, 3, 4, 5, 6, 1, 1, 2, 3, 4, 5. So if you see, it is 1, 2, 3, 4, 5, 6. So from 6 door, from every door we have 5 options. That means 6 into 5, which is 30. So this is the model 2. So if you are not getting the visualization, you will break it into this form and you will solve it. Okay. So this is model 2 type. Now we have some basic steps to remember. Now we gone through the first model and second model. ओके, फर्स्ट मॉडल और सेकेंड मॉडल से हम लोग हो चुके हैं. अब हमें कुछ बेसिक इंफॉर्मेशन, बेसिक नोट्स हमें ऊपर से पता चला. वो क्या पता चला कि हम लोगों को पहले करना है आइडेंटिफाई द इंडिपेंडेंट इवेंट. ओके, identify the independent events involved in a problem. So independent event is what? If you go in this thing, choosing any door is independent. So choosing any door is independent event. Okay. Now we choose one of the independent event, like we started from door 1. That was independent. Okay. Second step is number of ways of occurring of each event. Now what happened? We chose we chose one of the event, like entering from door 1. So we chose door 1. We went through door 1. Okay. Now after door 1, we have to become dependent in the sense that we are left with only D2, D3, D4, D5, D6. So if we enter from D1, we are left with only last 5 door. Okay. Now we are not available with D1. So what happens? This become independent. So the exiting from last doors are dependent on D1, but entering from D1 is dependent to nothing. We can choose any one of the door. Okay. So this is what I am trying to say in second point. And the second point is number of ways of occurring of each event. Now entering from D1, so D1 could happen as D1 D2 or D1 D3, D1 D4, D1 D5, D1 D6. So this is the occurring of the event. Okay. So now after that, third point is third point is multiply the numbers in 1 and 2. Okay, and total number of occurring is equal to whatever number that happened in 1 and whatever number that happened in 2. Okay, so what will happen? We are going to previous. In this first event is what? 1, 2, 3, 4, 5, 6. So there is six different event to occur independently. We can enter in any gate that is independent. But in second, you see, for first one we have only 1, 2, 3, 4, 5. Five dependent variables. So in any, if you see, it is 5. That means the second number is 5 and the answer will come out to be 30. So we went through completely basic, है ना? हम लोग ज्यादा एडवांस में नहीं गए, सिर्फ बेसिक में गए. हम लोगों ने मॉडल बनाया और मॉडल से हम लोगों ने विजुअलाइजेशन किया. हम लोगों ने प्रोसेस डायग्राम बनाया, कैसे क्या हो रहा है, और उसको मैथमेटिकली हम लोगों ने कैलकुलेट किया, है ना? तो ये बेसिक्स हो गया परमुटेशन कॉम्बिनेशन का. अब आगे बढ़ते हैं. We have few lexicographical illustration. अब लेक्सिकल ग्राफिकल इलस्ट्रेशन में हम लोग एक एग्जाम्पल के थ्रू समझते हैं. वी विल अंडरस्टैंड दिस थ्रू एन एग्जाम्पल. सो दिस इज द क्वेश्चन. द क्वेश्चन इज find the number of ways it is find find total number of find total number of 5 letters word that can be formed from the letter of word tough. Now we are given a word tough. We are told that how many different five letters word could be created from taking this. So what will happen? I think this word has also 5 different words. T, O, U, G, H. Yes. So we have 5 different words, letter words. Now we have to find total number of 5 different letters that could be formed using this. So we have 1, 2, 3, 4, 5 places for the word to happen. So in lexicography illustration, I am trying to say that if you think at this place, we can put any one of these 5. Is it possible? So we can put any one of these 5. That is possible. So five different thing can come here. Five different independent thing can come here. Yes. Second, now out of five, for example, one number has been chosen. So the number of left term is what? 4. If t has been chosen, the number of left word is what? 4, 1, 2, 3, 4. So any one of 4 could be chosen. Yes. For example, we chose O. Now we are left with only 3 U, G, H. So in this place, we can put only 3 numbers, 3 of this one. Maybe I have taken U. Okay. Now we are left with only 3, 2, G and H. So here we are available only 2 and we can put either G or either H. So only 2 different ways are there. Yes. Now when we choose this one, we are left with only this one. Now we have option for only one number, maybe H. So what happened? Right now we kept T, it could be O also, it could be U also, it could be G also, it could be H also. And if O is here, it could be T also. So it could be 3 different number. T, it could be 4 different number. Other than O, there could be 4 different number here. Similarly, if U is there, other than U, there could be 4 different number. So you can find that it is 5, then 4 number available, 3 letter available, 2 letters available, 1 letters available. So it is somewhere 5 into 4 into 3 into 2 into 1. So these many total numbers of 5 letters are possible using the word of tough. That is 120 different letters are possible. Arthmenda, I think you got it. So this is it. Okay. I think now you got the theoretical part. Let's start with the questions. This is JEE Mains hours, JEE Mains J Advanced hours. So we should be having question, the scenario for questions, okay? So there are 8 buses running from Kota to Jaipur, 10 buses running from Jaipur to Delhi. In how many ways a person can travel from Kota to Delhi via Jaipur? So first we will try to draw model 1. Model 1, we saw that Kota to Jaipur, Jaipur to Delhi. So we have Kota here. Everyone, you can try this question. Try this question. We are going Kota to Jaipur. Jaipur to Delhi. Okay. So what will happen? 8 buses are running. So we can have this as bus 1, bus 2, bus 3, bus 4, bus 5, bus 6, bus 7, bus 8. So we have 8 buses going from Kota to Jaipur. Okay, and 10 buses from Jaipur to Delhi. So 1, 2, similarly it will go up to 10th bus. Okay, so 10 buses, yes, and here 8 buses. So what will happen if you go from any one of the bus? So total number of independent event is how much? 8. Total number of independent event. We can choose any one of the bus, isn't it? And the second one, if you see, going through any bus is independent of the first one. So the total number of independent bus is how much? 10. So this is 80. Got it? So this is the total number of ways a person can travel from Kota to Delhi via Jaipur. Okay. So this is the way it works. Okay. How many number of ways 10 and 10,000 can be formed? The number between 10 and 10,000 can be formed by using the digits 1, 2, 3, 4, 5. If no digit is repeated in any number. Okay. So we have some good thinking level question. So number between 10 to 10,000. Okay. So numbers between 10 and 10,000. So 10,000. Okay. So what will happen? It is saying that we have to find number between 11 to 9,999. Yes. So one will be two digit number. In this we are going to have two digits number. That means this way, this way. So if you see, this is lexicography illustration type question. Second, we will be having three digits. There could be a number possible with three digit. Okay. And the third one is four digits. One, two, three. So there is four digits. One, two, three, four. Okay. See, here, if it has to be a two digit number, the number will be one or more than one on the first place. In we have 10 different digits: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 digits. But at this place, we are told that it is more than 10. That means any number coming here, if it is 1, okay, then here we can have digit other than 0 and 1 right now. Okay. So we are left with only 8 digits. Yes. So this is 8. Got it? If it is 1, then it is only 8 digit left. If we have any number other than 1, 0 is not possible other than 1. We are left with 1, 2, 3, 4, 5, 6, 7, 8. So other than 1 on the first place, we can have 8 possibilities, 8 independent event. Yes. Now we choose, for example, we chose 6. Now we are left with how much? 9 digits. So we can put any of the 9 digits here. Okay. So from here we are going to get 1 into 8, multiplication of first and second term, multiplication of first and second number. And we'll do sum of both of them, which is around 80. Okay. Now going for 3 digit number. So since it is 3 digit at one's place, at this place we cannot have 0. So we can have any number out other than 0. That means it can be 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9. That means we can have 9 different option available. Now we choose one of the number. For example, we choose 3. Okay, we choose 6. So 6 is kept here. Now we are available with how much numbers? 1, 2, 0, 1, 2, 3, 4, 5, 7, 8, 9. So we are available with 9 more numbers. So it should be unique. That means we can have any number out of the available 9 numbers. That means we have 9 different options available. Now for example we covered 2. So 6 and 2 has been covered. So at this place, the number that should come, that number should not be from 2 and 6. So the left numbers are how much? The left number are 8. 0, 1, 3, 4, 5, 7, 8, 9. So here we have 8 different numbers. So the total number of possible numbers are multiplication of all the 4 numbers, which is 9 into 8. Okay. Similarly, when we come to 4 digit number. Okay. So at first place we cannot have 0. We can have any number other than 0. That means we have total 9 possibilities. And when one of the possibilities, for example, we took 6. Now we are left with 9 different numbers. So out of 9, we have 9 different possibilities. So 9, we chose 2, okay? Now we are left with how much? 8 different possibilities. Now we chose, for example, 4. We are left with 7 different possibilities. So total number of possible numbers are 9 into 8 into 7, which is what we'll calculate. So total possible numbers are 80 plus 648 plus 9 into 9 into 8 into 7. Okay. So this is the way it goes. Part 2. I am giving you all few time to solve it. Kindly solve it. Okay, I'm giving you part 2. Take some time. I'm giving you time. So are you all done with this or not? Let me know. So yes, I think you got enough time to solve it. Now we are proceeding to the solution for this one. So in second part, when the numbers are allowed to repeat, okay? When the numbers are allowed to repeat, this is the line. Now we are allowed to repeat, isn't it? So when we have two digits, two-digit place, so what will happen? Our case is starting from 1. If it is 1 at first place, 1 at first place. So here it is 1. Now what will happen? We have to get more than 0. So for us, the availability is what? We cannot have 0. It should be between. That means it should be more than 0. So we can have 1, 2, 3, 4, up to 9. This is the possibilities at this place. So we have 9 possibilities. So can we say it is 1 into 9? Yes, sir. Now other than 1. If you put other than 1, so we have 2, 3, 4, 5, 6, 7, 8, 9. So other than 1 and 0. We can't have 0 and 1. So we have 8 different possibilities at this place. And now here we can have 10 different possibilities. We can have any number 0 to 10. So can we say that output of this is 8 into 10? Okay, okay. So now we have 3-digit numbers. So 3-digit numbers is more than 11, more than 2-digit number. So here we can have any number other than 0. Is it okay? That means we have total 10 digit. Out of that we are excluding 0. So we are left with 9 different ways. Now when one of the number is chosen, for example I chose 6. Now we are left with how much number? 9 different numbers. So we can have 9 or even all the numbers. 6 could also be repeated. It could be repeated, yes. Digits could be repeated. So 10, and again we are left with 10 because digit could be repeated. So it's simply 9 into 10 into 10. Now we are going with 4 digits. So we have 4-digit place 1, 2, 3. Okay. What will happen here? We can have number from 0 to 10 excluding 0. If there is 0, it will become 3-digit number. So we can't have 0. So other than 0, we have 9 different options. So we'll say it 9. Okay. Now here we can have 10 different options. If 0 also comes, it is going to be 4-digit numbers. So it is better to put 10, any number out of 10. And again here we have 10 different options, and again here 10 different options. So we have simply 9,000. So total numbers are 9 plus 80, 89 plus 900 plus 9,000, which is 9,989. So these many numbers are possible. Okay, in 4-digit, I'm saying to say in 4-digit number, this is 4-digit, okay? We have here 9 different numbers, excluding 0, 10 different, including all the numbers, including all the numbers, including all the numbers. So this is 9,989. So total number of digit is 9,989. So answer for this one. Okay, let's move ahead. How many 4-digit numbers are there without repetition of digit if each number is divisible by 5? So we got few cases is like 4-digit numbers. We have 1, 2, 3. 4-digit numbers are there. It should be divisible by 5. So divisibility criteria for 5 is what? Divisibility criteria for 5 is what? Last digit should be 0 or 5, isn't it? So it is 4-digit number. We'll keep this number as 0 or 5. Yes, that means we have two possibilities, and it should not be repeated without repetition. Okay, so what will we take? One case when 0 is at the end. So what will happen in 4-digit number? 1, 2, 3, 4-digit number. If 0 is at the end, and total number available with us is how much? 0, 1, 2, 3, 4, 5 up to 9. Yes, if we take 0 here, we are left with how much number? 9 numbers. We can have 9 numbers here. If we choose one number, we are left with how much? 8 numbers. If we choose one number, we are left with how much? 7 numbers. So from here we have how much? 9 into 8 into 7. This much number possible. Second, 5 is at the end. So we are keeping 5 at the end. That means it is a 4-digit number. 1, 2, 3. If 5 is at the end, so we took 5, okay? Out of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We took 5. We took 5 here, so only one possibility. Now we are left with 9 numbers, okay? So at this point, we can't have 0. If 0 will come here, it will become 3 digit. So we'll exclude 0 and we are left with only 8 number. We will exclude 0 and 5. We are left with only 8 number. So 8 different possibilities is there. Now when any number is chosen, for example, we choose 1 only. So we are left with, we are not, we don't have 1 and 5 with us. So we are left with only 8 numbers. Now here we can have 0. So we are left with what? 0, 1, 0, 2, 3, 4, 6, 7, 8, 9. That means 8 different numbers. And then if we took one of the number like 0, 1 and 5 has been taken. Now we are left with how much numbers? 7 different numbers. So total possible numbers are 8, 8, 7. So total number of 5 divisible numbers. 5 divisible numbers. This is 987. 9 into 8 into 7. And here we have 8 into 8 into 7. So it is simply 9 plus 8 into 8 into 7. We'll get the value and we got it. Let's move ahead. Using 6 different flags, how many different signals can be made by using at least 3 flags arranged one above the other? Okay, so using 6 different flags, how many different signals could be used? Taking at least 3. Okay, so first we take 3 flags. Okay, we have 6 different sample. Flag 1, flag 2, flag 3. Okay, flag 3, flag 4, flag 5, flag 6. So we have 6 different flags and we have to try to create different signals. Okay, so when we are using 3 flags, so we have 3 places. So we can tell that out of 6 we can choose any 6 here. Now if we choose F1, we have only 5 left options, so we can have any one 5. And then after 2 numbers are chosen, we are only left with 4. So what will happen? So what will happen? Total number of signals are how much? 6 into 5 into 4. Okay. So this much total signals are possible. 120. Okay. Now we are having 4 flags. 1, 2, 3. So what will happen? We are here with 6 flags. So here we can have any one of the flag. Here we can have any one of the flag from the left flag. Here we can have any number of flags from those two left flags. So two flags are chosen. That means we are left with 4 flags. Now three are chosen. We are left with only 3 flags. So total number of flags possible are 6 into 5 into 4 into 3, which is 360. Okay. Now we are going with 5 flags. For 5 flags, we have like this: 1, 2, 3, 4. So out of 6, we have 6 option here. We have 5 option here, 4 option, 3 option, 2 option. So we'll get simply 6 into 5 into 4 into 3 into 2, which is 720. If we have 6 flags, we'll go with this thing: 1, 2, 3, 4, 5. So 6 flags. So here we can have 6 different option. Here we can have 5 different option, 4 different option, 3 different options, 2 different option, 1 different option. We can say that it is 6 into 5 into 4 into 3 into 2 into 1, which is 720. So total number of signals which could be made, total numbers of possible signals are 120 plus 360 plus 720 plus 720. If we calculate, it is what? 1920. So this much signals are possible to be made. Okay. Let's move ahead. I would like to give you this as a homework. Take this as a homework. Take this as a homework. Take this as a homework. We have already covered such question in the class. I will try to solve this question. Okay. How many four-digit natural number not exceeding more than 4321? So it should be less than equal to 4321. Okay, this is the possibilities. So we have four-digit numbers. So we have one, two, three, four-digit number. and the number given are given numbers, given digits 1, 2, 3, 4. So what will happen if we have, so right now we are not taking the case of 4. If we have any one of the three here, if the first digit is any one of the three, that means any one of the three, that means 1, 2 or 3, any one of the three. So 1, 2, 3. So any one of the three is here. Then here we can have any four of them, isn't it? So repetition is allowed. So any four of them, that means 1, 2, 3, 4. Any four of them, any four of them, any four of them. So total numbers are 3 into 4 into 4 into 4. This is 192. Okay. So when there was only 1, 2, 3. Now when there is 4, 4 as first digit. If you go here, 1, 2, 3. Here we have 4. Now what are the cases? So cases are that if here we put 1 or 2, that means we have two cases. Then we can put any of the four number 1, 2, 3, 4. Because if it is 4, 1 something, 4, 2 something, it is going to be less than 4, 3, 2, 1, isn't it? So we can have one, any one out of 4. So 2 into 4 into 4. This is the possibilities. Now, second possibility is that if it is 4 and now this time it is 3. So we are moving to 3. And if there is 2, the only one possibility is 1 here. So only one number possible. And if it is 4, 3, 1, then any one of the four numbers are possible. 1, 2, 3, 4. So here we are getting 1. So what can we say? Total numbers less than equal to 4, 3, 2, 1 is how much? 192 plus 32 plus 1 plus 4. 9, 2, 2. 229. Okay. 229 is the possibilities. Let's move ahead. Find the number of all 5 digits which have at least one digit repeated. Okay. Okay, boss. So can we say that total number of 5 digits, we will find total numbers of all possible 5 digits numbers. So we have 1, 2, 3, 4, 5 places. So out of 0 to 9, we can have 9 digit. We can't have 0 here. Now when out of 1 to 9 we have 9 digit. Now out of 0 to 9 we can have 10 digit. Similarly 10 digit, 10 digit, 10 digit. That means total number of 5 digit is how much? 9 into 10 to the power 4. What we are going to do is that total number of distinct distinct total number of non-repeated digits, 5 digit number. So in 5 digit number, no digits are repeated. So we have 5 digit numbers, 1, 2, 3, 4. No digits are repeated. So here if we put, we can have 9 possibilities. Now if we have 0, 1, 2, dot 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 up to 9. If we select one of the number other than 0, if we put 0, it is not a 5 digit number. So we can put any number other than 0. So we kept 9. So we kept 9. So 9 different possibilities are there. We can have 1, we can have 2, we can have 3. So we can have 1 to 9 any digit. That means 9 possibilities. Now, if we selected 1, now we are left with 9 more digits because 0 could come here. So we have 9 possibilities. Now if we choose 0 here, for example, now we are left with 8 possibilities. Then we are left with only 7 and then 6. So what will happen in in order to get at least one digit, at least one digit repeatable. So at least one digit should repeat. What can we say? Total number of digit, total possible 5 digit number minus total 5 digits with no numbers repeatable, which could be 9 into 10 to the power 4 minus 9 into 9 into 8 into 7 into 6. So this is the total number of non possible numbers which has at least one digit repeating. Can we say that? Yes, boss. Let's move ahead. Okay. Solve it for the homework, homework, homework. Now we are going to next topic. Okay. Find the power of prime number in factorial form. Okay. So I will try to give you some small background. Okay. I will try to give you some small background. I am trying to say that if you understand from binomial theorem and factorial, meaning n, n minus 1, n minus 2, n minus 3, dot dot dot, 3 into 2 into 1. This is it. Example, if we take 4 factorial, can we say it is 4 into 3 into 2 into 1, which is nothing but 24. 5 factorial could be written as 5 into 4 into 3 into 2 into 1, which is 120. So similarly, we can calculate all the factorials. Okay, we should be knowing that 0 factorial is equal to 1 factorial equal to 1. Okay, so this is it. Now what will happen? We have a number. For example, I am taking one number. Okay, now I am taking a number like 100 factorial. We have a number 100 factorial. We have to find this as exponent of p. This can be have this thing dot dot dot. This could be represented in the power of 2, 3 in the power of prime. So 2, 3, 5, 7 dot dot dot. They are prime numbers. They are prime numbers. And P, Q, R, W dot dot dot. They are natural numbers. Okay. So how to find these powers? So to get powers of 2 will have some approach. Greatest integer of 100 by 2 plus greatest integer of 100 by 2 square plus greatest integer of 100 by 2 cube plus greatest integer of 100 by 2 to the power 4 plus greatest integer of 100 upon 2 to the power 5. So we'll continue this up to when the greatest integer is not 0. So this is 1632, 64. I think now after this we are going to get 0. This is point something something which is no going to be 0. If you see here, it is 50, it is 25, it is 8, 12.5 which is 12, this is 16, 6 ja, 32, 3 ja, 64, 1 ja. So if you see it is 75, 75, 15, 90, 97. So it is 97. We can say this it is 2 to the power 97. Similarly, powers of 3, 100 by 3, 100 by 3 square, 100 by 3 cube, 100 by 3 to the power 4. So this is 3 3 is 9, 81. If you go 3 to the power 5, it will come out to be 243, which is going to be 0. Which is going to be 0. It is greatest integer. Note that this is greatest. So this is not wrong, my dear. Your concept is half. It is not wrong. Greatest integer function. Greatest. I follow the steps. I am dividing 100 number with 2 and finding the greatest integer. So greatest integer, if you see, it is 333 ja, this is 9 11 ja, 27 3 ja, 81 1 ja. So we are getting 44 48. So it is going to be 2 to the power 48. So the answer is correct. I can see the answer in my notes. Okay, let's move ahead. If you have any doubt, you can ask me. For more guidance, you can connect me on my WhatsApp. Okay, for more guidance, connect me on my WhatsApp. Now, if you have more question, 100 factorial is divided into 24 to the power k. So 100 factorial is divided by 24 to the power k. Then what is that? So we can say that 100 factorial will be 2 to the power. Okay, you connect me, I will tell you. So it is 2 to the power a, 3 to the power b, 5 to the power c. So what happens? Using this we can find, if you find 24, it is what? 2 cube into 3 to the power k. This is 2 to the power 3k and 3 to the power k. Yes. So if you see previous question, we are getting 100 factorial as 2 to the power 97 and 2 to the power 48. So we are getting is 2 to the power 97 and 3 to the power 48. So what will happen? Uh, we'll try to make it like it should be 3k. So 332 is 96. So we can say that it could be written, if it is dot dot dot, it could be written as 2 3 3 32 into 2 into 3 16, and then 5 to the power c, 7 to the power d, dot dot dot. We don't care.